Discussing and the important topic of the NMR spectroscopy, that is to finding the number of the proton NMR signals by just using the structure of the compound. And it is very important, and many questions are asked in the BS, MS, MSc, CSIR, NEET, and the also in the CSS about this NMR spectroscopy, about this concept of NMR spectroscopy. So here this picture that is given is the benzyl alcohol, and this is the OH group, and this is here the two hydrogens are present. You should know that the different hydrogens that are of the different chemical environment give us the different signals in the proton NMR spectrum. So if you see here, if this is the hydrogen that is attached with the oxygen, this is one kind of the hydrogen, and these two hydrogens have the same chemical environment, because here these two hydrogens are attached in this neighbor OH and here in the benzene ring. So these two hydrogen give us the second type of the signal in the proton NMR. I will write here B and B. This benzene, if we see this benzene as the whole, this will give us a multiplet in the proton NMR spectrum. And if we are saying that this gives us the multiplet, we may see this is the third kind of the signal in proton NMR. But if this multiplet, if we see in the expansion, then you may see here that here no hydrogen is present. But here one hydrogen is present. Here one hydrogen, here one hydrogen, here and here. The hydrogens are present. If you now see here, this hydrogen and this hydrogen both have the same chemical environment, because here it is attached with this hydrogen, and here inside this is attached with the same kind of the group. So we can say that this is the third kind of the hydrogens in the proton NMR spectrum. Similarly, these two hydrogens have the same chemical environment, because here it is attached with the hydrogen in this side, and in this side it is attached with the carbon that is attached with this functional group. You may see this carbon, and that is attached with the CH2OH. So it will give us the fourth kind of the signal in the proton NMR if you see in the high resolution, and this hydrogen will give us the fifth kind of the signal. So the total number of the signals now that these different hydrogens will show in the proton NMR spectroscopy are in front of you. This is 1, 2, 3, 4, and 5. So this compound will give you the 5 signals. Okay. Now the other compound, second compound, is benzyl bromide. It is also somewhat like this. Here the hydrogens are present. If you see this, these two hydrogens have the same chemical environment. So we will see we will show it as the A, because both the hydrogens give us the same signal, and will give the same signal in the proton NMR, because the chemical environment is same. Chemical environment means the different kinds of the functional groups that are present in its environment. Both these hydrogens have the same. Here in the side bromine, and here in this side benzene ring. So it means that same signals are these two hydrogens will show us the same signal in the proton NMR spectrum. But here this benzene ring will give us the multiplet. If we consider it as a multiplet, then we can say that as a whole it will give us the second type of the signal. But if you see in the high resolution NMR spectrum, then you will find out that this multiplet also gives us the different signals. And here no hydrogen is present here in this corner, because the two are it is attached. This carbon is attached two bonds here, and this one bond here with the other carbon, and here with this carbon. So no hydrogen is present here, but here, and here hydrogens are present. So it means that in this benzene ring, 5 hydrogens are present. So these two hydrogens have the same chemical environment. Like this, if we divide it, these two hydrogens are attached here with this 3 hydrogen, and this is also attached with this 3 hydrogen, and here in this corner this is attached with the same functional group. So it means that this is the second type of the signal in the proton NMR spectrum. And now these two hydrogen, I am also dividing here a line. These two hydrogens here is attached with this hydrogen, and here in this corner with this 2 carbons that is also attached with the same functional group, like the carbon, and that is attached with the CH2 and the Br. So it means that these two hydrogens will give us the third kind of the signal in the proton NMR spectrum. But this give you the D. This is the separate hydrogen that is attached here with these two hydrogens, with these two carbon, and that carbon is attached here. So the total signals that you will get from these different kinds of the hydrogens will be 4A. The one from these two hydrogen, and the other with these two hydrogen, and the third one will be these two hydrogen, and the fourth one will be this hydrogen. So like this we can divide this structure, and then we can find out the different number of the hydrogens that are present here, and from those different type of the hydrogens, we can know about the signals that it will represent in the proton NMR spectrum. So here it gives us the code. Okay, wait now, this is the benzyl cyanide. This is the benzyl cyanide compound. So here carbon is present and here the two hydrogens are present. This is the same type of the structure just like the here, but the difference is that here the cyanide group is present rather than the bromine atom. So can you know that how many signals it will show? Yes. This first one. These two hydrogens are attached to the cyanide. And this is the single bond. It means that it can rotate. So these two hydrogens will give us the same functional group. Because only the magnetically non-equivalent compound hydrogens are present here, where where the bond is present, that is not rotatable. But here it can rotate, so this is the same kind of the hydrogen. So these two hydrogens will give us the same signal in the proton NMR, that is the A. And this here no hydrogen is present. So if you divide this benzene ring like this, and now you can easily find out the number of the different hydrogen. Here this hydrogen and this hydrogen will show the HB, means the second type of the signals that you will get in the proton NMR, and this hydrogen and here this hydrogen is the HC. This will give the third kind of the signal, and this hydrogen is HB. This will give you the fourth kind of the signal, just like this compound that is the benzyl bromide. Okay. Now this, if you see here number of the proton NMR signals shown by this structure, this is the structure. It is important structure. Like this is the benzyl amine, and mostly may be asked in your exams, these two hydrogens. Similarly, just like the bromine here, and now if we divide this structure like this, you should know that in high resolution, this your benzene will give us this type of the structures. Okay. These two hydrogens are exchangeable, and this will give you the one type of signal in the proton NMR. These two hydrogens will give you the second type of the signal. This is HC and this is also HC because these two hydrogens have the same chemical environment here and the same chemical environment here. And similarly, this is the HD. Why it is HD? Because the fourth type of the signals will be given by this hydrogen, and this will be the fifth kind of the signals that we are getting here, because this in the high resolution, this benzene multiplet will be separated out, and we can easily see that the different types of the peaks that this benzene ring will show us. So these two hydrogens that is exchangeable will give us a one signal, and these two hydrogens are chemically equivalent. This will give the second, and these HC are chemically equivalent. This is the chemically equivalent, and this is separate. So the total signals that you will get are the 5. Is it easy? Okay. Now, this structure. It is also easy. Here the two hydrogens are present. Similarly, here two hydrogens are present. And the benzene ring, same case. This benzene ring will give you the 3 signals. Acha, this one hydrogen is exchangeable. This will give you the one kind of the signal. And these two hydrogens will give you the second type of the signal. Both are HB. And these two hydrogens will give you the third kind of the signals. If you see why these two hydrogens are giving us the separate signals, if you see here, these two hydrogens are chemically equivalent, because here it is attached with the OH group and here it is attached with the CH group that is directly attached with the benzene, or you may say benzyl functional group. So these two hydrogens, now it is one side it is attached with the bromine, on the other side it is attached with the CH2OH. So it means these two hydrogens are chemically equivalent. Now on the high resolution, if we split the signals that multiplet that we are getting from the proton NMR, you will see that this will give you the fourth kind of the signals, HD, and this will be HP. Can you say that these two will be the chemical equivalent or not? These two hydrogens, yes, it is also chemically equivalent. So this will give you the fifth kind of the signal, and this hydrogen will give you the sixth type of the signals in the proton NMR. So like this hydrogen, this structure will give you the different signal. Okay, the structures that I have choose are symmetrical, not symmetrical. It means that and no hydrogen is chemically equivalent with the other type of the hydrogen if we cut the our structure into the different halves. So these are all asymmetrical structure. No symmetry is present here, and the no other half is chemically equivalent with this first half. So it is maybe these type of the structures may be asked in the exams, and mostly these types of the structures are asked because now the NMR is included in almost all the courses, and now the exams about the NMR are getting harder and harder. Okay, now the time about 1-phenyl ethanol. This is exchangeable validity. So this will give you the one kind of the signal in the proton NMR. Similarly, these methyl group, these three hydrogens are attached with the CH group that is attached with the OH and the benzene. So it means that these three hydrogens are chemically equivalent. These three hydrogens will give us the second type of the signal in the proton NMR. This will give you the third kind of the signal. These at is like separate, and these hydrogens in the benzene rings similarly same symmetry is present here. So it means that this benzene will give you the three signals like D, E and F. So the signals that we will get here are same number that are of 1, 2, 3, 4, 5 and 6. Now I think you are know that how the benzene ring will give us the separate signals in the proton NMR spectrum if some kind of the functional group is attached with it. Okay, if you see here the benzene and only the benzene is present, it also gives us the different signals, then no, it will not give you the separate signals. Like this. This is the benzene. And now in this benzene, all the hydrogens are of same chemical environment. If the same chemical environment hydrogens are present, so they will give the same kind of the signal. Now in this benzene, all the hydrogen are A. They will give the same signal in proton NMR, and their indication will be 6. They are only giving us a separate signal just because they are attached with some kind of the functional group, and this functional group is somehow giving the separate signals affecting the benzene ring, and by resonance power or by electron deploying or electron donating structure. If only the alkyl groups are attached with the benzene like this, if I draw here, this is your benzene structure, and only the methyl group is present. So this multiplet, it is not that separate. Even in the hybridization NMR, we will get only the multiplet because this methyl group is not have any large effect on the benzene. But now if the benzene ring is attached with some hydrogens, like OH group, then it will affect like some carbonyl group, carboxyl group. This will also affect the benzene very clearly, and we will get the separate signals. But I am giving you this possibility here. This is here, if you see this is the OH group, then it will affect the benzene ring very clearly. But now if you see here, in this is the bromine, and that is attached only with the CH group. It will not affect this benzene ring that high, and we can get only the multiplet here, and this will be separate in the very high resolution, very high power NMR spectrum. Okay. The next structure that we are getting is the methyl, is the benzyl methyl ketone. This is the methyl, that is attached with the carboxyl group, and this is the benzyl group. So the signals, similarly, same case here, the chemical environment, chemically same hydrogens, it means the same signal. These three hydrogens are directly attached with the C double bond O. It means the chemical shift value will be affected, but they will give the same kind of the signal. And here no hydrogen is present, no signal in the proton NMR. And here two hydrogens are present that are of the same chemical environment. It will give you second type of the signal, means B type of the signal. And this is the benzene ring. And similarly, if you divide the carbon atoms that of the same chemical environment, this will give you the third kind of the signal, HC, and this is HC. This will be the HB, and here will be the HD, and this will be your HE. So the signals that you are getting is 1, 2, 3, 4 and 5. 5 signals will be shown in the proton NMR spectrum. Okay, Now it is easy because I have already divided the signals here. Different hydrogens, chemically different hydrogens here are circled with the different colors. You see here, this is the different color. It means this will give you the one kind of the signal in the proton NMR. Chemically same environment these three hydrogens have. And similarly, these four hydrogens will give you the second signal in the proton NMR spectrum because these both are the same chemical environment. Here no hydrogen is present, and here also no hydrogen is present, and these four hydrogens have the same chemical environment. This will give you the third signal, and these two hydrogens, same chemical environment, will give you the fourth signal, and similarly, this will give you the fifth signal. So this number of the signals that you are getting in the proton NMR are just like this. If you divide them into the units, show clear. Okay, same case here. I have also divided the benzene, the different separate signals here. This is the hydrogen of the formal aldehyde. Like this is your aldehyde group, and this is your ketonic group. When the both sides the hydrocarbons are present, when on one side the hydrogen is present, this is your aldehyde group. So in the aldehyde group, the hydrogen always gives you the separate signal because this hydrogen is not chemically equivalent with any other hydrogen except the structure is formaldehyde. Here this hydrogen and this hydrogen is chemically equivalent. So that's why we get the same signal. But in all other, we get always the separate. So now you see here this hydrogen have the separate group chemical environment. Why? Because it is attached to the carbon that is attached to the CH3 group and on the other side with the benzene. So it will give you the second signal. This will give you the third signal. Benzene as a multiplet will give you the fourth signal. But if this multiplet is further divided, the benzene will give you the third three signals. Here, this will be the hydrogen C, and these hydrogens will be as D. And this hydrogen will be as E. So, in the high resolution, you will get the 5 signals. Same case here. I have also divided here for your easiness. So, number of the proton NMR signals are shown by this structure. I can also leave this structure. You may also comment me in the section that how many signals are present here. It is easy. I have already separate the different kind of the hydrogens that are of different chemical environment. You will tell me about the signals that are present when this benzene ring will act as a multiplet in the low resolution NMR spectrum, and also you will tell me about the signals, how many signals this will give when this compound is we have taken the NMR signal of this compound in the high resolution NMR spectrum. This is also just like the previous one, so that's why I am leaving this. Okay, now this is our structure. If you see here, these three hydrogens of methyl, 9 hydrogens means, and here no hydrogen is present. These 3 methyl group are attached with the carbon that is attached with these functional group. Will it have the same chemical environment? Yes, these will have the same chemical environment because all these 3 hydrogens in these 3 groups have the same chemical environment, so they will give the same chemical shift value. It means they will give the same type of signal in the proton NMR, except that their integration value will be 9. So all these 9 hydrogens are of HA type. It means that they will give the one signal in the proton NMR. Here no hydrogen is present, here no hydrogen is present, and here 2 hydrogens are present. And now 2 hydrogens are present here, and if you see here, these 2 hydrogens are of same chemical environment. So this will give you the second signal in the proton NMR. Similarly, this methyl group will give you the third signal, and all the 3 hydrogens here are of HC type. So this will give you the C signal. So the total signals that you are getting in the tertiary butyl acetoacetate are 3 in the proton NMR. Now this is the ethyl formate. This is the CH3 group, and this group is attached with the CH2 group that is directly attached with the O and then aldehyde group. It means that forward group. So here, this will give you the one type of the signal as A, and these two hydrogens will give you the second type of the signal, that is the B. Because both these hydrogens are of chemical environment. Here no hydrogen is present, no hydrogen is present, only one hydrogen is present here. This will be the Hc type. So, because this is the chemically different with the other hydrogens. So, these three hydrogens of same chemical environment are giving us the same. And these two hydrogens are of same chemical environment are giving us the second signal. And these third hydrogen is Hc. And this will give you the third type of the signal. So, the total signals that you are getting here are of three types. Yeah. It is very interesting compound. This is the compound of the benzyl and very interesting. First of all, just rolled out here. No hydrogen is present. And I am just very happy to see this structure. As you see here, this is the ketonic group and this is also a ketonic group. And this is attached here with the benzene ring and here also benzene ring. I said about this some type of this symmetry here. Now we are dividing this structure. Now we have divided this structure. Okay, now if you see that here this structure and this structure are of the same chemical environment. So it means that the hydrogens that we are getting here, the signal, these type of the hydrogens here will also give the same signal. Like this. This hydrogen and this hydrogen is of HA type. Similarly, this hydrogen is, and here this hydrogen will also of the A type. Why? Because if you see here, this carbon is attached to the carbon that is directly attached to the carbonyl group. Similarly, here also it is attached with the carbon that is directly attached to the carbonyl group. It means there is some type of this symmetry. And in this symmetrical compounds, where this symmetry is present, where it can be divided into the parts, into different halves, into halves that are of the same type. So now, if you see here, the signals that we are getting here in chemical shift value, same signal we will get here in the same chemical shift value. Same chemical shift value means same chemical environment. And if the same chemical environment is present, it means those hydrogens will have the same peak area in proton NMR and will give us the same signal in the proton NMR. So these four signals will give us the same, these four protons will give us the same signal in the proton NMR. Okay, now if you see here, this hydrogen here, this, and here this hydrogen. This is HB, HB, same case here, HB and HB. It means that these four hydrogen will give us the same type of the signal in the proton NMR, and this is the HC, and similarly this is the HC. So in the benzyl, we will get the 3 signal in total. Yeah, here is also some type of the symmetry is present. And these structures are very easy to conclude. So here the 2 hydrogens are present. Similarly, here 2 hydrogens are present. And these 2 hydrogens here and these 2 hydrogens here both are of the same chemical environment. Means they are all of same type, means giving the same signal. So this will give us the same signal. Here no hydrogen is present. Here no hydrogen is present. And now this is the HB type. Similarly, this is HB type. As this symmetry is present in this structure, so here this will be the HB type and this will be the HB type. Because these 2 hydrogens and these 2 hydrogens are of the same chemical environment and will give us the same structure here. And this is HC. Here, this also give us the same signal as HC. Yes. This will also give us the same signal as HC because these are also chemically equivalent. Chemically equivalent means symmetry is present. So the hydrogens that we are getting, that giving us the signal here, will also give us the, this hydrogen will also give the same signal. And now, the last one, that is, this is the HC and this is also HD. Sorry, this is also HD. So the total signals that we are getting here are of 4 types. Okay. Now we will find the NMR signal for this compound. Here the nitrogen is present that is attached to the hydrogen. That is exchangeable. It means this is the one kind of the hydrogen. Exchangeable hydrogens means only one is present and this will give us the one signal. And here if you see this hydrogen, nitrogen, this side of the nitrogen and this side of the nitrogen are of the same chemical environment. This means that these two CH2 group here, two hydrogens. Similarly here, two hydrogens are present. And these hydrogens are of same chemical environment. Like how here if you see these two hydrogens are attached to the carbon that is attached to the NH and on the other side with the benzene ring. Similarly, this is also like this. Now I can divide this structure like this. And this is giving us the same signal. So these four hydrogen leading to the HB signal is second type of the signal. And here no benzene, no hydrogen is present. And similarly, this hydrogen will be C type. But as you know that benzene being its symmetry can also be found as you see here. This carbon is attached with the CH2 group NH and so this is HC. And similarly, here is also like this. So this will also give you the HC signal and here HC signal. And here HB signal and this will be HD signal. And this will be HE signal. Okay, what about these two hydrogen are of the same chemical environment like the HB? You may see this is attached with the CH. Similarly, it is attached with the CH and here is HE and here it is also attached with the H type signal. So this will be the HB and this will be the HE. So the total signals that you are getting here in this compound are of 5. Okay, this is the proton NMR signal shown. Structure is also symmetrical here somewhat. Like this. I have divided. This is H and this is also 2H group here. So if I say these are HA, why these are HA? Because symmetry is present. These four hydrogens are of same chemical environment. Similarly, here the methyl group here also methyl group and the methyl group. These methyl group and these methyl group are of same chemical environment. Why? Because it is attached with the nitrogen that is attached with the CH2 and here from this symmetry is present. Similarly, the CH3 and the CH3, these are also attached with the nitrogen that is attached to the CH4. It means these four hydrogens are of same chemical environment. With the same chemical environment, then it will give you the V-type signal. This will also give you the V-type signal. So, only two signals are present in the proton NMR, but these signals give you the methyl group. This will give you the integration value of 12. Means 3 methyl groups are present here. Are you understanding why it is giving you the two kind of the signal? Because of the same chemical environment. These four hydrogens are of the same chemical environment and these 12 hydrogens means these 4 methyl groups are of the same type of the hydrogens. Oh, now also this symmetrical compound is present. Here CH2 group and here also CH2 group. These two hydrogens here in these two CH2 groups are of the same chemical environment. It means they are giving you the one type of the signal. Similarly, here the methyl group and here the methyl group, these are attached with the carbonyl group that is attached with the CH group. Similarly, it is attached with the carbonyl that is attached with the CH2 group. So, it means that both these methyl group will give you the second type of the signal that are of B type. So, the total signals that we are getting in the proton NMR are of 2. And here, you may see these two H group are present and this is the CH3. Here also 2H group and CH3 is present. This is all of A type signal. This methyl will give you the A type signal and these two hydrogens are different from this methyl. We will get the B type signal. Okay, here no hydrogen is present, but if you derive the compound from here, this carbonyl group is attached with all this carbonyl is full. Okay, so this is the carbonate as a whole. If you see here, this is the carbonate. this is the carbonate, and this side of the carbonate is attached with the CH4, this side of and CH3. This is also attached with the CH4 and CH3. So this CH3 is also attached with the CH2 and the carbonate. So it means this will also give you the A-type signal. Similarly, just like this CH2 group is attached with carbonate on one side and this methyl on the other side. So this will also give you the B-type signal. So the total signals that you are getting in the proton NMR spectrum of the diethyl carbonate are of two types. Okay students, if you are understanding my videos very well, then please subscribe my channel and share my videos. I hope to get support from you. Thank you so much.